It's almost science fiction. Scientists say the shape of Earth's inner core is changing. Scientists who just months ago confirmed that Earth's inner core recently reversed its spin have a new revelation about our planet's deepest secrets. They identified changes to the inner core's shape. Earth's innermost layer is a hot, solid bowl of metal surrounded by a liquid metal outer core. For decades, planetary scientists suspected that the solid inner core deformed over time as it spun. Now, researchers have found the first evidence of changes taking place over the past 20 years in the shape of the inner core. Signs of the core's deformation appeared in waves from earthquakes that were strong enough to reach Earth's center. The research team used that same earthquake data for a 2024 study to resolve a long-standing debate over the inner core's rotation. They found that the inner core once spun faster than Earth itself. But beginning around 2010, the solid inner core's spin slowed. It's now revolving backward relative to the rest of the planet. Their new study, published Monday in the journal Nature Geoscience, builds on that discovery using earthquake data gathered from 1991 to 2023. The scientists' prior work on core rotation helped them interpret variations in the height of seismic waves, defining them as indicators of changes to the surface of the inner core, said Dr. John Vidali, a co-author of the previous study and lead author of the new study. We can compare the signals that we see when the inner core is returned to the same position as it was in some other time and see if there's differences that can't be explained by the rotation. Vidali, Dean's Professor of Earth Sciences at the University of Southern California's Dornsife College of Letters, Arts, and Sciences, told CNN shape changes in the core could hold clues about the forces deep inside Earth that power our magnetosphere, the invisible lines of magnetic energy that protect our planet from solar weather and deadly radiation, the researchers reported. Earth evolves on a geological time scale, so observing changes on an annual time scale is always intriguing as it enhances our understanding of inner core dynamics, said Dr. Yoshi Miyazaki, an associate professor in the Department of Earth and Planetary Sciences at Rutgers University in New Jersey. Previous studies have already discussed how inner core rotation has changed over the past decade, and this study introduces a new perspective, non-rotational changes, adding another dimension to the discussion. I believe this will further fuel these debates, Miyazaki, who was not involved with the new research, told CNN in an email. Almost science fiction of all Earth's layers, the inner core is the most remote and mysterious. This solid sphere of iron and nickel is about 70% the size of the Moon, with a radius of approximately 759 miles, 1,221 kilometers. Temperatures in the inner core are as high as 9,800 degrees Fahrenheit, 5,400 degrees Celsius, and pressures can reach up to 365 gigapascals GPa, more than 3 million times greater than Earth's average atmospheric pressure on land. While direct observation of the core is impossible, scientists study it by analyzing changes in the size and shape of seismic waves as they pass through the core. Earthquakes generate two types of waves. Primary waves, or P waves, are the first waves produced by a quake and move the ground in the same direction that the wave is moving. Shear waves, or S waves, are slower than P waves and move the ground perpendicular to the wave's direction. Amplitude changes in a type of core-penetrating P wave, PKIKP waves, hinted at deformations in the inner core's shallowest level, according to the new study. At the boundary where the solid inner core meets the liquid of the outer core, the sphere's surface might be more malleable than it is at deeper levels. It's almost science fiction to visualize what's happening on the surface of the inner core, Vidali said. It's a place that's so different from our day-to-day lives, with different time scales, different materials, and incredible forces. And yet, we can get down there and learn more about it by just sifting through some of the latest observations. Movement like landslides, the scientists analyzed 168 paired waves from quakes in 40 to locations near the South Sandwich Islands, a chain of volcanic islands in the South Atlantic Ocean. Tracking the speed and direction of the core's rotation gave the researchers a way to detect changes in the shape of the core. Once they knew the core's rotation speed, they could model its position and then compare different PKIKP waves that reached the core as it revolved into the same spot. Amplitude changes in those paired waves could then be assigned to shape changes in the core rather than rotation changes, according to the study. However, what that deformation of the inner core might look like is harder to pin down. Maybe the topography is going up and down. Maybe it's sloughing around like landslides, Badali said. The most likely thing is the outer core is just pushing on the inner core and moving it around a little bit, while just one inner core location showed signs of deformation between 2004 and 2008. There may be more that are yet to be detected, the researchers reported. It's hard to know if we are looking at an anomalous or a normal location, Badali said. But one guess would be that some amount of deformation is happening fairly often in many places. As Earth's solid inner core spins, the molten outer core churns and sloshes. Their interactions generate magnetic energy, which unspools to enfold our planet in the magnetosphere, but the liquid outer core is shrinking. Millimeter by millimeter, the inner core has siphoned molten metal from the liquid core surrounding it, Badali said. It likely took billions of years for the inner core to cool and solidify, and over the next few billion years, the inner core will continue to cool, sipping drops of liquid metal from the outer core until Earth's entire core is a solid metal sphere, he added. That'll kill the magnetic field, Badali said. There won't be the moving iron down there anymore. However, such an event is billions of years in our future. And before that could happen, Earth will likely be obliterated as our sun expands into a red giant and swallows the inner planets of the solar system, Badali said. Until then, scientists should have ample time to investigate the unseen workings at the heart of our planet and discover what Earth's internal spinning, churning, and shape-shifting might hold in store for the planet. Regarding the impact on life, as mentioned in the paper's introduction, inner core growth plays a crucial role in generating Earth's magnetic field, which protects us from harmful solar radiation, Miyazaki said. While a direct connection between life on Earth's surface and the ICB inner-outer core boundary remains distant, what happens at the ICB still has some implications for Earth's long-term evolution.